Okay.
Go to present review.
Okay, so this is our hackreason2025 project, which is a cyberbullying detector.
Okay. I can say this. So, for the problem statement, around 46% of U.S. teens report that they have experienced some sort of cyberbullying. So, cyberbullying is a consequence of social media usage that's only going to see an increase if measures aren't taken to prevent such cases from happening. And one measure solution that we discovered is we can leverage SCAPs and common sense reasoning to detect which messages promote cyberbullying.
So some challenges with solving the problem are that we need an effective set of rules to make actual detections of what counts as cyberbullying and what doesn't count as cyberbullying. So we've divided these up into different things, and then different combinations of them will lead to different descriptions of cyberbullying in different levels. So, for example, depending on the context, the same text could count as cyberbullying or not cyberbullying, depending on how close the two people are. So, coming up with something that relates to this and gets over that problem is core to the model.
Next page. So for the solution outline, it involves creating and connecting the front and back end and writing the SCAP logic to kind of make inferences to identify cyberbullying, and then using the LLM to translate the input message into values, and then converting the Python back to SCAPs to get the results.
And for this project, the design came from the need for common sense reasoning. So that's the main reason we use SCAPs for this. And the integration of SCAP not only provides a robust backbone, but it also just ensures transparency in decision making.
Solution evaluation. The solution is somewhat effective. The system's multi-layered approach improves its ability to detect both overt and subtle cyberbullying. By considering multiple factors, the system can identify subtle bullying in addition to direct threats. And also, the nuanced language can lead to occasional false positives, which need to be minimized for greater accuracy. Backend performance is also good. The integration of GPT-4o Mini enables fast processing. However, handling a high volume of requests could increase cost due to API usage, and the server could experience strain with a large number of simultaneous users. Overall, the system offers a strong solution for detecting cyberbullying in text messages, combining LLMs with logical reasoning. And while it does show potential for practical application, ongoing optimization will be necessary to address edge cases, refine detection accuracy, and ensure optimal performance as it scales.
So
Lessons learned.
you can go ahead.
All right. The core of having good detection system is to plan out the reasoning to automate common sense.
And I think that's it.
All right, and we'll go ahead and show our demo now. I'm gonna switch screens.
Okay, so this is the website. So if you just go ahead and you type like a message you think might be cyberbullying, for example, you're stupid, right? So if we click submit here, you see it's going to tell you if your child is being bullied or not, and so that is an example, a use case of how this website might be helpful for detecting cyberbullying. That's it, right?
Do you want to show any of the code off?
Uh, I could show it, but I don't know. I'm not gonna like explain it.
Oh yeah,
You know.
just show it. You don't have to explain it. We can
Okay,
explain it.
okay. This is the website, by the way.
So here you can see that we did the front end using Node, which connects to Python in the back end. And then we use Flask to interchange messages and information between them. And then since we did the back end in Python, Can you go to the server.py? Since we need the backend in Python, I was able to connect the Python to the OpenAI library. And since I have an OpenAI account, I could just use tokens and access the API from there. So what we do is we get the text input from the JavaScript page, give it to the Python file, then the Python file interacts with OpenAI's GPT-4o model, and then it returns a list of facts to be converted to Prolog back to the Python file. And then everything happens in reverse to get it back to the web page. So that should be everything.
And then if you want to show the class logic too.
I don't think we got time. We only got 2 minutes.